I am Gurpreet Kaur from Chemistry Department of GGN Khalsa College. Today I am going to start with my next topic, that is delocalized chemical bonding, which is also known as resonance theory. This resonance theory is the extension of DDT and it makes it useful for the structural description of the complex molecules. So what is resonance theory? It is hypothetical state or non-real state of a species in which its electronic structures can be hypothetically represented by two or more resonating or canonical structures. But the properties of chemical species depends upon the resonance hybrid. Resonance hybrid is the combination of all the canonical structures, and resonance hybrid is a real state of a chemical species which can't be represented by Lewis method. So we take help of canonical structures as they are represented by Lewis method. Moving on to the elements of resonance theory. So first point is, all the canonical structures must be written according to the Lewis method. That is, they can be represented by bonds, lone pairs or formal charges where required. Secondly, the position of atom nuclei must remain same. For example, taking the example of the helium. And the canonical structures, they are represented by double-headed arrow nuclei. If we write a structure by taking this nuclei, hydrogen nuclei here, must remain unchanged. Third point, only the pi bonds can be converted into lone pairs and vice versa. Taking the example of protein. So here I am converting the pi bond into lone pairs. Or I can change the direction from here to here in this case. Or we can say that this lone pair can be converted into pi bond from this structure. Coming to the fourth point, the number of unpaired electrons in each canonical structure must remain same. Taking the same example, if we write one more structure, in this structure we have two unpaired electrons, and in all the other three structures there is no unpaired electron. So as we know that the number of unpaired electrons in each structure must remain same, but here we have two unpaired electrons, so this is not a canonical structure of propylene. resonance must lie in same plane. So there should be planarity in the molecule for resonance to take place. Because if there is deviation from the planarity, then the resonance will diminish, because the maximum overlap can't be possible in that case. So further moving on to the contribution of resonating structures. More the stability of resonating structure, more will be its contribution towards the resonance hybrid. And the stability can be determined by certain empirical rules. So these rules are given. The first point is the structures with more covalent bonds are more stable and more contributing towards the resonance hybrid. So taking the example of 1,3 butadiene. So in this case, out of all these structures, this structure has more covalent bonds. So this is more contributing towards the resonance hybrid. Second point, if there are same number of covalent bonds, the uncharged structure has more contribution. So taking the example of vinyl amine. So in this case, both these structures have same covalent bonds, but this structure is uncharged, so it will contribute more towards the resonance hybrid. Third point, structures with isolated unlike charges have less contribution. So taking the example of phenol. So in these cases, in this case, this one is more contributing towards the resonance hybrid because this structure is uncharged. Now if we have to find out the stability between these two structures, then we will stick to this rule. The structures with isolated unlike charges have less contribution. That is, this structure where the negative charge is on para position. Here the charges are more separated, more isolated. So this has less contribution, or we can say least contribution towards the resonating hybrid. Fourth point, the structures with negative charge on electronegative atom and the positive charge on less electronegative atom are more stable. So taking the example of unsaturated aldehyde. by taking it here. So, out of these three structures, this one is more contributing because there is no charge in the structure and there are total charges on these two structures. So, if we have to find the stability between these two complexes, then we have to stick onto this empirical rule, which says that the structures with negative charge on electronegative atom, negative charge on electronegative atom, and the positive charge on less electronegative atom will be more contributing and more stable. So this complex has, this structure has more contribution as compared to this structure. Fifth point of empirical rule is equivalent resonating structures are more important than non-equivalent one. So taking the example of carboxylic acid, and I will write this resonating structure. And if we remove this hydrogen atom, we will get carboxylate ion. In case of carboxylic acid, we have two structures which are not equivalent because this is uncharged, this one is charged. And in carboxylic ion, we have two equivalent structures. So, as the rule says, equivalent resonating structures are more important. So this means that the resonance in case of carboxylate ion is more important as compared to the carboxylic acid. Then the sixth point involves isovalent resonating structures are more significant. So let's take the example of benzene. So, what are isovalent resonating structures? The structures which have same number of covalent bonds. So, these two equivalent structure of benzenes, they are isovalent resonating structure because they have same number of covalent bonds. And these two are also isovalent to each other. And this bond can't be compared to this one. So, these are isovalent to. So, these two structures, they are heterovalent to these two structures. These two structures are isovalent to each other, but these two structures are heterovalent to these two structures. And these two isovalent structures are more contributing towards the resonance hierarchy of benzene. Then the seventh point involves the structures with electron deficient atom has less contribution. So taking the example of diazotropine, we can draw a structure which we can show the nitrogen atom as electron deficient atom. So in this structure, there is deficiency at nitrogen atom. So here the octet rule is violated. So it has less contribution towards the resonance hybrid. Then 8th point involves greater the number of resonating structure, more will be the stability of resonance hybrid. 9. More delocalization of charge, more is the stability of species. What is delocalization? Delocalization is distribution of electrons over whole molecule encompassing all the carbon atoms.
So